Connaissance.
Recherche.
Sciences.
Des sciences. Mathématiques.
Théorie.
Physique.
Philosophie.
Conférence.
Archéologie. Environnement. Nature.
Mesdames et Messieurs, je vous remercie de m'avoir invité à prendre la parole à ce colloque. C'est un grand honneur de pouvoir présenter mon intervention dans ces institutions très fameuses pour l'histoire de sciences ici en France et en Europe. Mais je suis désolé que mon français parlé, ce n'est pas assez bon pour me parler en français. J'espère que vous comprenez quand je parle en anglais. And I want to talk about the census of Antarctic marine life, which has been arguably one of the most successful and largest biological activities under the International Polar Year. It was made possible through the combined interactions of the Scientific Committee on Antarctic Research, the Alfred P. Sloan Foundation in New York, who provided considerable funds for scientific coordination, and the International Polar Year. And these three organizations came together, and we are on the brink of being able to deliver a status report on the marine biodiversity around Antarctica. But when we started, the public attitude to marine research was, as shown perhaps in this small picture from the New Yorker, where the ladies are saying, "I don't know why I don't care about the bottom of the ocean, but I don't." That's a very common response that one comes across when talking about marine biodiversity. Most of it is out of sight and therefore out of mind. But when the International Polar Year presented an opportunity to work internationally to understand the greatest part of the surface of the globe, the idea quickly caught on. The Census of Antarctic Marine Life, CAML, is part of the wider Census of Marine Life, being funded by the Sloan Foundation and organized out of New York. We have managed to provide 18 major voyages, which I have tacitly described as Rolls-Royce voyages, Toyota voyages, and, 2CV voyages. The big, the medium, and the rather small research voyage. But in particular, I want to speak a bit about a voyage entitled CMARC, the Collaborative East Antarctic Marine Census, in which France was heavily committed, along with Australia and Japan. Over 200 scientists have participated in our census. That's 200 scientists at sea and dealing with the samples on land. We have rescued considerable quantities of data from old notebooks, research information which scientists leave in boxes in their offices when they retire. We have spent a lot of money obtaining all this information and putting it into the Skar-Marbin Biodiversity Information Network, which has been the cornerstone and the rock of everything we've done in CAML. During the 2007-2008 Antarctic season, we were able to conduct this number of voyages around Antarctica. Some were Rolls-Royces, that is, ship time provided only for the census. Others were very small voyages where maybe only 1 or 2 days was provided for scientists to obtain marine information. You see the names of the ships down here, and there are 1 or 2 that are not even included. About 350 sites have been sampled. When we started the census, When we started the census of Antarctic marine life, there had been about 12 samples only of the deep sea. We now have got up into 3 figures of numbers of samples from the deep sea. That's more than 3,000 meters. We've used many sorts of sampling equipment, 24,000 nautical miles of continuous plankton recording. We have returned 15,000 sample lots to laboratories around the world. 900 special barcode of life samples have been taken. We think there will be 200 or more papers being written on the census of Antarctic marine life, and we know of 40 graduate students that took part just in the at-sea activities. Many more are working in laboratories around the world. I mentioned the database, the SCAR-MARBIN, SCAR's Marine Biological Information Network. It now has more than 14,000 marine taxa in it. There's a register of Antarctic marine species, which has 8,500 vouchered specimens that we know are correct. And we have more than 1 million georeferenced data points. And we have done that through bringing together more than 100 databases, going back over many years, but 100 databases of marine information. So this is if you can follow the colors, if you have a particular group of animals you're interested in, you can see how we're building up this pattern of information about marine biodiversity. Out of it are coming a number of quite interesting analyses. Previously, we believed that the Antarctic region was composed of a series of different sorts of subregions. But we've now found that there's no evidence for an east-west difference, no evidence for South Georgia being different from the rest of Antarctica, no relation with Tristan da Cunha, and the South American islands are quite distinct from the New Zealand islands. And so what we have now produced is a new bioregionalization of Antarctica, which shows that from the marine biodiversity viewpoint, we simply have 3 zones, 3 habitat types, one around Antarctica, another going east from the southern tip of South America, and one in the New Zealand sub-region. In our collaborative East Antarctic Marine Census, we used 3 ships, the Aurora Australis from Australia, l'Astrolabe from France, and the Umutaku Maru from Japan. And Dr. Philippe Kubi from Villefranche-sur-Mer, he was the pelagic ecologist aboard the Umutaku Maru. And aboard the Aurora Australis, we had a dynamic group from the Natural History Museum here in Paris, led by Dr. Ozouf. That group produced a very vibrant website. Sophie Mouge looked after the web production and every day sent back information to a number of schools she was working with in various parts of France. And that work continued until just a few months ago, when there was a schools parliament here in Paris that Sophie and other people from the Natural History Museum took part. We've been extremely fortunate in CAML to have obtained the services of many institutions that are very skilled at delivering material around the world, and particularly here I would pay tribute to Équipe Cousteau, who have been very helpful in establishing part of our public outreach. And indeed, our public outreach has been very considerable, with over 800 press items so far. Here is Dr. Catherine Ozouf, ready for jumping into the Southern Ocean, I think, aboard the Aurora Australis. And this photograph came from one of the posters that was around the Jardin des Plantes in the period from November until early January of this year. Well, what are we beginning to discover then about climate change in the deep Southern Ocean? And it's already an important point has already been made a little earlier today. It is very difficult, not to say dangerous, to work in the Southern Ocean. So it is hard to obtain the sort of information that we have got. And for those of you who work in the Antarctic, you know that you need 5 times or 10 times as much time to get one data point as you do elsewhere in the world. Well, we've been looking very specifically at whether there is an ecological phase shift in the plankton in relation to climate change, and we believe there is. Here is a picture of this part of the Southern Ocean before 2000-2001, and we had a number of species in the permanent open ocean zone. Well, what we are now finding is that in the sea ice zone, there are some of these species that are crossing from the more open ocean heading southwards, a direction which the penguins that we've just been hearing about, the Adelie penguins, also know about. In the sea ice zone after 2000 and 2001, we see that there are quite a number of changes are occurring. Let me just do that again. We find that we're getting a larger number of species which previously have been further north. We believe that there is a distinct shift to the south of species living in the Southern Ocean. And in the permanent open ocean, 2004-5, we get a plankton structure that looks like that. But what we're finding is that certain foraminifera are becoming much more abundant. And that has an effect, of course, on the whole food chain. And where this will lead, we don't know. This information is coming through the Census of Antarctic Marine Life, and there is much more analysis which is necessary. We've heard a little bit about acidification. The A is missing. Acidification of the ocean, that the uptake of carbon dioxide is making the water acidic and making it difficult for plants which require calcium carbonate for their shells and their skeletons to be able to live. And one of our objectives in the census has been to identify the maximum depth at which the saturation of carbonate allows this very dense assemblage of organisms. It almost looks like they almost look like dense plants. And that figure at the moment appears to be at about 850 meters. One of the legacies of the census will be to monitor the level at which those organisms, which need to draw calcium carbonate from the water, can survive. We would predict that that level will come higher and higher as the years go forward and as the ocean becomes more acidic. We've examined the sea floor underneath ice shelves, and we've taken the opportunity of the Larsen ice shelf, which collapsed in 1995, and the Larsen B, which collapsed in 2002. And we've been able to get one of our expeditions into the Larsen B, and we find that very quickly the top predators move back in, the whales and some large fish. But the response to the benthos is slow. We're being able now to identify some early colonists, and these solitary ascidians are amongst the early colonizers. Deep sea species are rare. There are many undescribed species that we're picking up from the survey, and the effect of iceberg scouring is very apparent a long time after the ice has disappeared. As far as the deep ocean is concerned, we've examined the deep ocean and find unexpectedly high biodiversity. We have at the moment more than 700 new species of isopods awaiting description. 52%, more than half of all species, are defined as rare. It's a complex zoogeography, and the distribution patterns are very patchy. The scale of diversity is quite astonishing. We have a volume in deep sea research which describes some of this, and in the middle of next year there will be another special volume of deep sea research which will describe the scientific work of the Census of Antarctic Marine Life. We've also been conducting some work on ocean currents and speciation, making use of deep-sea octopus. Deep-sea octopus are difficult to study because they don't have many hard parts. They're very soft, and only they have beaks, so the genetic relationship is poorly known. What we've been able to do using new genetic aging techniques is to look at the effect of the Antarctic circumpolar current and its role in distributing species well into the north. And from it we have the view that the Antarctic is a hotbed of speciation. It's an area where there is active speciation going ahead. And if you've looked at the publication État de la recherche polaire, you will see this work is described in there as one of the significant findings, or one of the significant outcomes of the biological work in IPY. Sea spiders are particularly interesting organisms, and that's why we chose one for our logo. And we're beginning to get the view that sea spiders are in fact circumpolar. Maybe they don't move quite as quickly as this one here, but their distribution is circumpolar. But they also move through the main thermohaline distribution routes northwards into the great ocean basins of the world. And we're hoping that the genetic work, which is currently underway, will let us look further at the role of the cold temperature, the dense water, the thermohaline circulation, and benthic speciation. The French group who were with us on the Seamark voyage have examined fish larvae, rare species of fish, and giant species of the deeps, and these starfish are amongst the largest invertebrates that we have yet been able to discover. Together with our colleagues in Équipe Cousteau, who have been working with Google and Google Earth and the ocean layers and the Cousteau layers on Google Earth, we've been able to create some pictorial representations of the evolutionary history of a number of species. There are just two examples given here. One is a bipolar species, a starfish called Hymenasta, and this is the deep-sea octopus about which I was speaking. These new visualization techniques are bringing the Southern Ocean alive to people living all around the world. We've looked at the evolutionary history of the deep-sea species, and we're now of the view that there have been successive waves of submergence as species move down off the continental shelf and then subsequently come back up from the continental shelf. And the genetic work is very powerful to help us resolve these interesting biological questions, but ultimately interesting management questions concerning marine biodiversity. We've already seen some societal impacts of our work. The Commission for the Conservation of Antarctic Marine Living Resources declared 2 vulnerable marine ecosystems. 2 areas for special protection were identified from samples and seafloor photographs that were taken last summer during the Camel Seamark voyage. And that, I think, is a great tribute to the power of good visualization and how, once you've got that visualization, people will take notice. The future? Well, there has been such a vast amount of goodwill, international goodwill, through the Census of Antarctic Marine Life, that there's no way we can stop now. The interest within the Antarctic Treaty System on bioregionalization and marine protected areas indicates that biodiversity data from the marine environment is vital, essential for creating new areas to be protected. The United Nations General Assembly, Resolution 51 on ocean sustainability, cries out for research of the kind that the Census of Antarctic Marine Life has been doing. I'd like to think that SCAR might be prepared to coordinate a repeat CAMEL, maybe in 2018, in 10 years' time. Having experienced and lived through one census of Antarctic marine life, which we did in about 4.5 years, I would say 10 years is about the right time to coordinate it. But what about GeoBon? What about the Group on Earth Observation Biodiversity Observation Network, GeoBon? It's a new global partnership to collect, manage, analyze, report, and share data relating to the status of the world's biodiversity. I think that organizations like this, or partnerships like this, represent the future for us. And with the very good amount of international goodwill that our project has been able to show, and the data it's been able to deliver, suggest that we have got a really good future. Perhaps CAMEL will become part of GeoBon. Thank you very much for your attention.